Welcome to the tutorial for the MuAlloy toolset. In this video, we will show how to use the MuAlloy toolset by stepping over its command line interface, which is provided through the bash script also named MuAlloy. On the left is an example Alloy program. Since the introduction of AUnit, as an Alloy developer, I can now generate tests to build confidence in this program. But as with any test generation effort, I am left to wonder if I'm creating a strong test suite. We will show how this toolset can help the developer perform mutation testing and thus get a gauge on how strong their test suite is. Additionally, we will show how this toolset can even generate a test suite for the user. First, to build MuAlloy, just run the --build option for the script. If successful, you should be alerted by the output of the command. Next, we will use MuAlloy to generate non-equivalent mutants so that we can later perform mutation testing. If we want, this is the action that can also produce a mutant killing test suite for a target alloy model. To generate mutants, we invoke the script with the --generate-mutants option. This option requires two arguments. The first is the path to the model we want to generate mutants over, and the second is the directory where we want to store the mutants generated. The next two arguments are optional. The scope argument specifies the scope to use for checking equivalent mutants and for generating the run command for any tests produced. If this is not specified, then the default Alloy Analyzer scope of 3 will be used. The last argument is used to specify the path to which you would want to save a mutant killing test suite. If this argument is not provided, then no test suite will be generated. When you run the command, you will see the number of equivalent mutants and non-equivalent mutants explored by MuAlloy. Additionally, if you've provided a test path, you will also see the number of tests generated. Notice that this can be less than the number of non-equivalent mutants. For each non-equivalent mutant, MuAlloy generates a counterexample and encodes the counterexample into a test which is able to kill that mutant. Sometimes, the same counterexample is able to kill multiple mutants, and that is why MuAlloy can generate less tests than the number of non-equivalent mutants. These test suites do not take a long time to generate and are strong by construction. All one needs to do is provide a human oracle over these tests by checking if they are passing or failing, which can be done with the visual aid in the Alloy Analyzer. To run mutation testing, just use the --run-mutation-testing option of the script. The command requires 3 arguments. The first is the path to the original model, the second is the directory where the mutants are stored, and the third is where you specify which test suite you want to run mutation testing with. Here, we pass the same arguments used to generate mutants. If we run the command, MuAlloy reports whether each individual mutant is killed or not. It also computes the mutation score for the test suite. Since we are using a test suite that was generated to kill all mutants, we would expect that it does indeed kill all mutants. As we can see from our output, this result is consistent with our expectation.